Trigonometric functions. First, you need to know the unit circle cold for sine, cosine, tangent. You realize that cosecant goes with 1 over sine, secant 1 over cosine, cotangent 1 over tangent. One way, if you do have any trouble with remembering this, if you look at the first letters for the secant and cosecant, cosecant goes with it, C goes with S, S goes with C. You'll never have S go with S. Just a little thing there. The basic, all 6 are periodic functions. By definition, a periodic function is f of x plus p equals f of x for all x, where the smallest p is the period. For sine, cosine, cosecant, secant, the period is 2 pi. For tangent, cotangent, the period is pi. Let's take a look at a couple graphs here. Sine graph, we have a domain from negative infinity to infinity, and we have a range from -1 to 1 inclusive. And we'll look at cosecant in just a second, cosecant being our 1 over sine. Whenever I graph cosecant, I'm always graphing sine first. Sine of 0 is 0, and so it's going like this. And then we can go on the other side as well. We have 1, -1. Whenever you're graphing a sine cosine type of graph, I want you to label 5 points. If it's the origin, you don't need to label that one. So basically where it hits high, mid, low, mid, and over here we don't need to keep on going for the whole thing. We could just say 3 pi. So there's our sine graph. Now cosecant. Cosecant's 1 over sine. 1 over 0 would make it undefined, so we'll have an asymptote there. We have 1 over 0 here, 1 over 0. So every place that sine is 0, cosecant will have an asymptote. If we look here and say, okay, at 1, or pi over 2, sine is 1, 1 over 1 is 1. We're looking at cosecant 1 over sine. These sine values are getting small. They're going towards 0. So what is the reciprocal of those values going to? You can think of it like 1 over a half, 1 over a fourth, 1 over a tenth, 1 over 100th. The reciprocal of those are getting big, 2, 4, 10, 100. So that value is going up. Similarly, it would be over here. These are parabola-like shapes. They're not parabolas. Parabolas don't have asymptotes. On this case over here, 1 over -1 is -1, and we're going to do the same thing, but now we have all negative values for the sine, so the reciprocal will also be negative. So it's going to shoot down to negative infinity. And once you realize that, you could just go ahead and draw those pieces. What's the domain of this? Well, what values don't work? 0, pi, 2 pi, 3 pi. So x cannot equal pi n. The range would be, we're going to look at negative infinity to -1, including -1. So we'll have a bracket, union with, bracket 1 to infinity. Let's look at tangent. Tangent is sine over cosine. Tangent is undefined when cosine of x equals 0. If we're looking at a unit circle, which I absolutely love, and I'm telling you already that you need to know that, you have cosine is your x value on the unit circle, whereas x equals 0 at these 2 spots. So those ones cannot happen. X cannot happen equal pi over 2 plus pi n. So we're going to look at pi over 2, and we'll have an asymptote there. Now, people get confused whether or not which one you're looking at. Is it tangent, cotangent? Does it go up? Does it go down? If you look at tangent of 0, you get 0. And then say, okay, in the first quadrant, what can you say about sine and cosine? Sine and cosine are both positive, so that means these values have to be up here. Now, I'm not starting off as if you didn't know anything, so you know it's going to have these kind of shapes, and once you have the first piece, you know every other piece is going to be similar to that. So this will be pi, since it is periodic, and this would be negative pi. And our range on this would be negative infinity to infinity. Odd-even functions, cosine of negative theta, we can say, for simplicity's sake, we're going to call theta a positive number. So if we look at negative theta, that would be down here. That would be negative theta. It could be in any quadrant, but just to make it easy, we'll look at it there. How would this compare to the cosine of theta? Cosine of theta would be up here. On the unit circle, cosine gives us our x value. What can you say about the x value of those two? They're the exact same thing. So the cosine of negative theta equals the cosine of theta. And if that's true, f of negative x equals f of x. This is even. Sine of negative theta is the y value. The y value here is negative. And the sine of theta is positive. So it's negative of sine of theta, which makes it odd. Tangent, you could say, is the y over the x value, so a negative over a positive, and then tangent of theta would have to be positive, so this will also be the opposite. You could plug it in as sine over cosine. Sine of negative theta is negative sine theta. Cosine of negative theta is cosine theta. Negative sine over cosine is negative tangent. Graphing equations. We have a general function equation, a f of b times the quantity of x minus c plus d, and we look at that with the sine. We call them sinusoidal graphs. We don't use cosine typically because all sine cosine can be written with either function. So what I want to do in this problem is graph this equation. So the first thing we're going to need to do is put it in that form. Actually, even before that, let's talk about what these letters mean. What is A? A is affecting the y values. Is A the amplitude? No, it's not, because A could be negative, but the amplitude cannot. How do we make it positive? Absolute value. Amplitude. What is B? Now B, a lot of people memorize and they say, oh, I know how to find the period from B. What does B represent? B is the number of complete cycles or periods in one normal period. And the reason why I say one normal period, because we could apply it for any of the trig functions. For sine or cosine, the normal period is 2 pi, but for tangent, it's pi. So we understand this. We have complete periods, B complete periods in one normal one. That gives us B periods equals 2 pi, or in other words, the period is 2 pi over B. C is our horizontal shift, and then D would be our vertical shift. So when we're looking at this problem number 1, we need to put it in this form. Right now the 4 is not there, so we're going to need to factor that out. So it would be 2 sine 4 x plus pi over 4, and then all of that plus 3. So what's going on here? What's the 2 doing to the graph? It's going to stretch it vertically. The period will end up being 2 pi divided by 4, or pi over 2. We're going to have a shift of pi over 4, shift pi over 4 left, and 3 up. Now I like to, when I have all 4 spots being done, I usually graph this twice. The first thing I would start to do is just graph a sine graph. This value is now 2. The bottom one is -2. We know this is pi over 2 since that's the period. Now, since we have to label our 5 values and 0 not included, how do I find these other ones? Well, how many intervals are there in a complete period? We're going from mid, high, mid, low, mid. There's 1, 2, 3, 4. What can you say about all 4 of those? They're all equal. So 1/4 of the period would be pi over 8, which means that this would be pi over 8, 2 pi over 8, which reduces to pi over 4, 3 pi over 8, and then 4 pi over 8, which is pi over 2. Our domain for sine would just be -infinity to infinity. We're going to write that down. We're going to need to do a little bit more to get the range. So we have -2 to 2. Now we're going to shift that up 3 units. We'll go 1, 2, 3. That is where the x-axis is moving to. That is going to be our line of symmetry. I shouldn't say line of symmetry. It's our midline. And then we're going to take all these points here and shift them pi over 4 left. So instead of starting at the middle, it's going to go pi over 4 left. Instead of starting at the middle, it's going to go pi over 4 left. So we have negative pi over 4. And since our 1/4 of the period is pi over 8, we're going to be incrementing in pi over 8 intervals. And once we have those, we can just say it starts at the mid, it goes high, mid, low, mid, and it's looking like this. We don't need to continue on and draw a whole lot. We could do one more, and we know this will end up at pi over 2. And that's it for graphing that. Let's take a look at the next part. The domains of sine and cosine are, I didn't finish the range for that problem. Our range values will be from 1 to 5. Oh, I forgot to label my scale. There we go. All right. The domains for sine and cosine are -infinity to infinity. Do these have inverses? Think about that question. The answer is no. How come? Because they don't pass the one-to-one test. They don't pass a horizontal line test. So if you think about that, when we're graphing that sine graph, if I were to flip that on the y-axis, that does not have an inverse. But we have this inverse button on our calculator. How do we do that? How do we deal with that? What we need to do is restrict the domains. What do we restrict the sine graph to, and what do we restrict the cosine graph to? What we want to do is make it pass the horizontal line test and also include the first quadrant. So looking at sine here, as soon as I get past this max here, it starts coming down, it's not going to pass the horizontal line test, so I'm going to have to stop it there. I want to include the first quadrant, so that means I'm going to have to go from negative pi over 2 to pi over 2. Similarly, for cosine starts at the high value. We're definitely including the first quadrant. If I go into the negatives here, it won't pass the horizontal line test. So I'm going to stop it at 0, and then I'll stop it over here at pi. So I go 0 to pi. And then tangent similar to the sine, except you can't include the endpoints because tangent of pi over 2 and negative pi over 2 is undefined. Given theta equals the inverse secant of 25 over 7, find the exact values of these 6 inverse functions. Well, how are you going to do this? This says that the secant of theta equals negative 25 over 7. For theta, what kind of values? Well, theta is going to be for the same as cosine. That's going to go from 0 to pi. And the similar cosecant would be the same as sine. Now we'll set up a right triangle. Where is cosine negative in the first 2 quadrants? It's going to be in the second quadrant. This is adjacent. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. We have 25 and 7. Which one is negative? The hypotenuse is never negative, so that's telling us the 7 is a negative. And you could do your calculation to say y squared equals 25 squared minus 7 squared, which gives us 576, so y is 24. Sine would then be opposite over hypotenuse, 24 over 25. Cosine would be negative 7 over 25. Tangent would be opposite over adjacent, so negative 24 over 7. Cosecant would just be the reciprocal of sine, so 25 over 24, or hypotenuse over opposite. Similar, well, we already know what secant is, negative 25 over 7, and then cotangent would be negative 7 over 24. Solve this equation. For 0 to 2 pi. Secant, let's change it into cosine. If you have 2 fractions are equal, their reciprocals are equal, so we'll get cosine of x equals root 3 over 2. Now what I want you to do is draw it on your unit. Cosine is x on the unit circle, so we're looking coming out here, x is 1 there, root 3 over 2 is about 0.86, 0.87, so it's pretty far over. We're going to have a line going through, it hits it in 2 places. What are those 2 values? That would be pi over 6 and 11 pi over 6. What if there's no restriction on this? Then there are an infinite number of answers, so we must include pi over 6 plus 2 pi n, and then 11 pi over 6 plus 2 pi n. Number 4, a lot of people want to use a calculator. Just say no to that. What is an inverse trig function? You should know that and know it without thought. An inverse trig function, is an angle. So when we're looking at this, we'll say let theta equal the inverse sine of 9/13. So that tells us that sine of theta equals 9 over 13. For what values can theta be? That's what we just did above. That's negative pi over 2 to pi over 2. So when we're looking at this, we'll draw a quadrant. We're in the first quadrant. Since it's positive, it's opposite over hypotenuse. We need to find out what x is. X will be the square root of 13 squared minus 9 squared. Would that be 169 minus 81, which will give us 88, or in other words, 2 root 22. So now what we're trying to do, here's theta. We want to find the tangent of theta. And that's going to give us 9 over 2 root 22. And again, we don't have to rationalize that. Cosecant theta, here's a find cosecant theta for this point is on the terminal side of theta. We're going to go -2, 3. Technically this is our angle, but as long as we take into account the signs SIGN, we don't need to worry about that. We'll drop the line down to the x-axis. We'll label the pieces. This would be -3, this would be, -2, this would be 3. Our hypotenuse would be the square root of 13. Now we can just say cosecant of theta equals what? Cosecant's 1 over sine, so it's hypotenuse over opposite. The last one,